In this video, we're going to take a look at order of operations and evaluating expressions. So the big idea of order of operations is given some mathematical expression with numbers and mathematical operations, we need to know how to calculate that expression. In other words, which operations do we do first? Which operations do we do second? Here we have a mathematical expression with numbers and operations. 2 times the quantity 4 minus 3 plus 6 times 5 raised to the third power. Now, if we want to do that, we have multiplication, we have subtraction, we have addition, we have exponents, we got parentheses in there. When we want to know what to do first, we turn to our order of operations. Our order of operations tells us which operations to do first. The first thing we have to pay attention to with order of operations is the idea of parentheses. That is where I have to simplify something inside before I can move on to the outside. Now, parentheses is a broad term for the category that includes any time we have to simplify inside. So we can have brackets or parentheses, or sometimes it's just written in a way that's obvious that I have to simplify this before I do the next operation. The second in the order of operation list is the operation of exponents. So exponents, and anytime we have any sort of power rules, come next. Again, exponents stands for a broader category that includes some other stuff, but parentheses and then exponents. Third on the list is multiplication. Now, once again, multiplication is a stand-in for different operations. We can multiply, divide, and apply negative signs. Those are all in this category that we call multiplication in our order of operations. And then lastly, in our order of operations is the category of addition. And in the category of addition, we have addition and subtraction. So we have essentially 4 categories of operations. We call them parentheses, exponents, multiplication, and addition. You may have heard the term PEMDAS. PEMDAS is when they combine multiplication and division. So they put M and D together, and then A and S together is the OS sound of PEMDAS. I like to think of it as this: 4 different categories: parentheses, exponents, multiplication, and addition. And you may ask, well, why is multiplication and dividing and the negative sign application all in this category? Or why is addition and subtraction all in the category of addition? Well, that's simple enough to explain. If we did have division, something like 2 divided by 4, I can turn that into a multiplication problem by, instead of dividing by the number, just multiply by the reciprocal of that number. So 4 has a reciprocal of 1/4, so 2 divided by 4 is the same thing as 2 times a fourth. Similarly, if I'm subtracting, 7 minus 12 is the same thing as 7 plus a negative 12. So every subtraction problem can be rewritten as an addition problem. Every division problem can be rewritten as multiplication. And then applying a negative sign in the multiplication is like multiplying by a -1. So -9 is the same thing as -1 times 9. So that application of the negative sign is also in the multiplication realm as well. So that's why I like to think of the order of operations as four categories. First, we pay attention to the parentheses, next to the exponents, then to the multiplication, and then to the addition. Let's go ahead and use the order of operations to evaluate these two expressions. And the reason I'm looking at these two in particular is because they have a mixture of operations in the same category. In this first one, where we have 8 times 9 divided by 3 times 7, that only has operations in the multiplication category. 10 minus 3 plus 5 minus 2 minus 1 plus 6 only has operations in the addition category. So the natural question is, when we have different operations and they're all in the same category, which ones do we do first? And the short answer is we move left to right, just like we were reading English. So we move left to right. We do the 8 times the 9 first. That gives me a 72. And then we divide that by 3, and then we multiply that times 7. And so I would divide 72 by 3. That gives me a 24. And then 24 times 7 becomes 168. Oftentimes, when people memorize the word PEMDAS, instead of thinking about it in 4 categories, oftentimes people start multiplying before they do their division. And so if you multiplied the 3 times the 7 before you did the division, you would not get 168. The correct answer is 168. And we want to think of it as those 4 categories because of this. So move left to right when we have 2 operations on the same level. You can do the same thing here. I won't probably do every step, but 10 minus 3 is 7, plus 5 minus 2, minus 1 plus 6. If I think about all of this as addition versus subtraction, you just keep going step by step. So 12 minus 2 minus 1 plus 6. And then 10 minus 1 plus 6. And then 9 plus 6. And then that's 15. Oh, I should put an equal sign in front of all of these. But there you go. So we get 15 there. Now, another way to do this is just to think about this as on the number line, we do 10 plus, think of this as 10 plus a negative 3 plus a positive 5 plus a negative 2 plus a negative 1 and then plus 6. Now we have all addition. And if you think about these things as negatives, it really doesn't matter what order we do this in, because anytime I combine 2 of these, it's addition. I don't have to worry so much about rewriting this. I can still go left to right, but I can also think of 5 plus negative 2 minus 1 plus 6 and simplify that whole thing. And then I get 10 plus negative 3 plus 8. And notice that adding those three numbers gives me 15. Doesn't matter what order. And what I'm trying to get at is if you put everything as addition, addition has the property that any two numbers, when you add them, the order doesn't matter. So we have the commutative property of addition. And if we write everything as addition, then order doesn't matter on how I add these things up. One last little thing about this is the following. Your calculator should obey order of operations. If you have a calculator that can do operations and specifically multiple operations, then when you plug that expression into a calculator, 10 minus 3 plus 5 minus 2 minus 1 plus 6, it should be able to give you a 15 as long as you type it in correctly. The same thing is true on this one. If you type in 8 times 9 divided by 3 plus 7 into a calculator, it should be able to give you 168 when you hit enter. Again, you have to type it in correctly, but should get 168. Oh, excuse me. So let's try to do an order of operations problem, or I should say order of operations problems, where we have more than one operation going on. So we have both of these two expressions, and I want to use order of operations to evaluate these two expressions. Go ahead and push pause on the video and try these on your own if you'd like. In a couple of seconds, I'll show you how each is done. All right, now you can type this into your calculator as one line on your calculator if you do it right, but I'll show you how to do a step-by-step approach right now. The first thing I would do is simplify what's inside the parentheses. So I take the 4 minus 3 inside of those parentheses and subtract and make that equal to a 1. And then what I would do after that is I'd apply exponents. By the way, this was the original expression that we saw at the very beginning of this section. So I'd apply exponents. And 5 to the third is 125. So this is 2 times 1 plus 6 times 125. Then I can apply multiplication. 2 times 1 is 2. 6 times 125 is 750. And then lastly, I'd add. So I'd get 752. Now you should be able to plug that expression into your calculator. And if you type it into your calculator correctly, it should give you 752 immediately when you hit enter. So when you ask for the answer, it should give you 752. Let's take a look at this expression. We have negative 7 squared minus 6 times the quantity 3 plus 19. The first thing I would do, let me hit equal just so we know that expression. The first thing that I would do is I would simplify what's on the inside of this parentheses. 3 plus 19 is equal to 22. Then I would apply the exponents. Now here's where it gets a little bit tricky. If you're doing this by hand, you have to realize that this negative sign is outside of the 7. So when we apply the exponent, I just apply it to the 7 and not to the negative sign. That gives me negative 49 minus 6 times 22. Again, the reason why that is, if I had negative 7 squared, what that's telling me to do is do negative 7 times 7. So negative 7 times 7. If someone would have written the negative sign inside of the parentheses, that would have meant to take negative 7 and multiply it times another copy of negative 7. Obviously, you get 49 when you take negative 7 times negative 7, but you get negative 49 when you take negative 7 times 7. So be careful whether the negative sign is out front or in parentheses, inside of parentheses, or outside of parentheses. At this stage, if I was doing this by hand, I'd take the 6 and multiply times 22. That's 132. So that's negative 49 minus 132, which gives me a final answer of negative 181. So that's how we would apply order of operations by hand. Like I said, most of the time when I do these, most of the time I just type things into my calculator. But I do have to be really conscious about how I type things into my calculator. We'll get into more of the how you type things into your calculator when needed in the problems later on in this class. Now, the other part of this section that I want to go over is evaluating an expression. Now, when we say a mathematical expression, we're talking about some combination of numbers, variables, and mathematical operations. Variables are just inputs for numbers, and so they have to work and behave like numbers. And what we do when we evaluate an expression is we plug in numbers for those variables. And then using the order of operations, we calculate our results. So evaluating an expression just means plug in numbers for variables and evaluate the results. So let's take a look at an example. Here we have the mathematical expression 7x minus 2, and we're asked to evaluate that expression when x is 3 and to evaluate that expression when x is negative 5. Let's start out with evaluating the expression when x is 3. So all I would do is I'd put 7 and then in parentheses I'd put in the 3. That's the standard because I don't want to think that this is 73. 7 next to an x means 7 times x. So this isn't 73. If I didn't put any notation in, if I just put 7 and then a 3, it looked like 73. So we put our numbers when we plug them in, oftentimes into parentheses. And then I can either type that expression into my calculator, or I can do order of operations by hand and get a 19. We'd have to multiply 7 times 3 is 21, and then subtract 2 to give me 19. With the next one, we can evaluate that same expression if the variable takes on the value of negative 5. So we'll have 7 multiplied times negative 5, and then I subtract 2. When I do that, I can either plug it into a calculator and get a negative 37, or do it by hand. 7 times negative 5 is negative 35, minus 2 is negative 37. So we can evaluate the expression for lots and lots of different values for x. In fact, you could plug in any real number you wanted for x and then evaluate that expression. Let's look at another example. Here we have the expression x squared plus 9x plus 5, and we want to evaluate that when x is negative 2 and when x is 7. Go ahead and push pause on the video if you'd like and try this on your own. In a couple of seconds, I'll show you how it's done. All right, so when I plug this in, plug in negative 2 for every value of x. Again, we usually plug in the negative 2 inside of parentheses. That's actually very important in this case. So when I plug in that negative 2 inside of parentheses, make sure I have the negative on the inside of the parentheses. Because remember, this x squared, a squared means x times x. Right? That's what x squared is. So I want the negative 2 to multiply times another negative 2. And so when we plug things in inside of parentheses, I get that. If I just plugged in negative 2 without the parentheses, in other words, if I'd have plugged in negative 2 squared, this is not the same thing as the negative 2 inside of parentheses. I'll do one extra step here. Normally, I would just write the answer, but we have 4 plus a negative 18 or minus 18, and then plus 5. So when we combine that, we get negative 9. The reason I wanted to give that extra step is because I want to emphasize that negative 2 times another copy of negative 2 gives me a positive 4. And if I would have written negative 2 squared this way, I would have gotten a negative 4. So be careful on how you write that negative 2 squared. And we always want to plug things in inside of parentheses when I have that option, for the most part. Now, when I plug in 7, it's not quite as important on that first term to have it inside of parentheses, because 7 in parentheses squared is the same thing as 7 squared. But it is important to put the 7 into parentheses on the second term. And there you go. We get 7 squared plus 9 times 7 plus 5. And again, you can do a step-by-step approach, or you can type that into your calculator and get 117. Either way will get you 117. 7 squared is 49. 9 times 7 is 63. And then 5, obviously. So there you go. That's how we can evaluate an expression like this, which includes exponents and multiplication and addition in this case. Now, in the first two problems, we only had one variable, and the variable there was x. But we can also have expressions with multiple variables. Here we have 4x minus 7 times y squared. And we can evaluate that expression when we know the value for x and when we know the value for y. So in this example, it says evaluate that expression when x is negative 1 and when y is -3. And then also evaluate that expression when x is 7 and when y is 2. Go ahead and push pause on the video. Try this on your own. In a few seconds, I'll show you how this is done. All right, so we're going to plug in -1 in for the x value, and then we'll plug in a -3 in for the y value. And I'm going to be sure to do that inside of parentheses when I do that. And in this case, I'm going to get, well, that's going to give me a -4, 4 times -1. That's why we always want to do it inside of parentheses, because then it looks like multiplication. If you don't write that, sometimes this will look like 4 minus 1 if I didn't have the parentheses. And then -7 times 9. So we'd end up with -4 minus 7 times 9. 7 times 9 is 63. So -4 minus 63 is -67. I'll just write the answer there, because you could just have used your calculator to get that value. In the other case, we do 4 multiplied times 7 minus 7 multiplied times 2 squared. The 2 is going to get squared before I multiply times the 7, and then what's going to happen when it's all said and done is we're going to actually get 0. We're going to end up with 28 minus 28, and that gives me 0. And 0 is perfectly fine. That's an answer that we can get. That's a real number. That's a whole number. That's an integer. So it's perfectly fine answer to get. Let's do this example. Here we have 8 times x1 minus 4, all divided by 3 times x2 minus 6. And we'll evaluate that expression in these two cases, when x1 is 12 and x2 is 5. And then we'll evaluate when x1 is 9 and when x2 is 2. By the way, x1 and x2, those are in the subscript spot. The 1 and the 2 here are in the subscript spot. They're not referring to any operations. They're just referring to our first variable x and our second variable. So our first variable and our second variable. So it's just like x and y. And the reason why sometimes people use x1 and x2 rather than x and y is because you run out of letters when you deal with things with lots and lots of variables. So oftentimes, if you had like 60 variables, you'd run out of letters. And therefore, you'd want to use something like x1, x2, x3, all the way up to x60. Go ahead and push pause on this video and see what happens when you evaluate the expression in these two cases. In a couple of seconds, I'll show you how each is done. All right, in this first case, what we would do is we would take 8 times 12 minus 4, and that's in the numerator. And in the denominator, it's 3 times 5 minus 6. Now, this separation between numerator and denominator is division. Whenever we have fractions, we have division. But it's written in such a way that it's like a parentheses. It's actually in the same order of operation category as a parentheses. I can clearly see that this is written in such a way that I need to simplify the numerator and then simplify the denominator before I actually divide. So what I'm saying is that it's written in such a way in which I need to simplify numerator. By the way, 8 times 12 minus 4 would be 92. 15, or excuse me, 3 times 5 minus 6 would be 15 minus 6, which would be 9. So I get 92 divided by 9. And by the way, there's a number of different ways you can write this. You can write this as an improper fraction simplified. I'll do that first. As an improper fraction, it is 92 over 9. You can write this as a mixed number. That's 10 and 2/9. Or you could write this as a repeating decimal, 10.2222 repeating. So that's 10.2 repeating. You just write a line over the 2 because that's going to be 2.22 and so on and so forth. And you could also round it to some decimal place. You can round it to 1 decimal place or 2 decimal places. In this case, if you rounded it to 2 decimal places, it'd be 10.22. So there's a number of different ways to write that, whether it's an improper fraction, a mixed number, a decimal with repeating value, or a rounded to 2 decimal places. But the key thing is, because of the way it's written, we simplify the numerator, simplify the denominator, and then divide. We can do that in this example as well. We do 8 times 9 minus 4. That is all in the numerator. And then in the denominator, it's 3 times 2 minus 6. In this case, the numerator becomes 68. The denominator becomes 0. Now, dividing by 0 is a problem in the real numbers. So whenever we divide by the number 0, this expression is undefined or does not exist. And oftentimes, when the expression does not exist or when it's undefined, then we just shorten that to just DNE as the shorthand version for does not exist. Dividing by 0 on your calculator would give you an error. And it should say a divide by 0 error or something like that. Sometimes it'll say domain error. Sometimes it'll say divide by 0 error. So this is an undefined expression when x1 is 9 and when x2 is 2. And the problem with it is that we cannot divide by 0. Most of the time, we get fairly nice numbers. Sometimes we can write those numbers a variety of ways, but there are the occasional instance where we end up with an expression that does not exist or an expression that is undefined. So that's what it means to evaluate an expression. It just means plug in the numbers into that expression, into the variables of that expression, and then calculate and evaluate the result. So we will do that throughout the entire class, and we'll see a lot of different examples within the chapters of and within the videos that we'll look at in this class.